Okay, 3 times bracket x plus 3 and bracket x minus 2. So this, they want us to expand and simplify. What this is when we have brackets like this, do you remember FOIL at all? You remember hearing that term?
Yes.
Yeah, so we're going to go through FOIL. And what that means is we multiply the first terms by each other. So what I'm going to do is I'm going to leave my greatest common factor, which is a 3 here. I'm going to leave it to the outside. I'm going to deal with this, and I'll try to color code it for you. So x times x is our first terms, which gives us x squared. Then we'll do outside terms. X times negative 2. This is the farthest to the outside. This is the farthest to the outside. Negative 2 times x is negative 2x. Next is I, which stands for inside terms, which is our 3 inner x, so the closest to the inside. So 3 times x is positive 3x. And finally, our last terms, positive 3 and negative 2. This is going to give us negative 6. Okay. We're going to combine our like terms inside. X squared I can't combine with anything, but the negative 2x and the 3x I can combine. Okay, they're both technically the power of 1. So I would add or subtract their coefficients. Because it says negative 2 plus 3, negative 2 plus 3 is just positive 1. So it's like writing positive 1x minus 6. Is that okay so far? Yeah. And then finally, we've simplified inside of the bracket as far as we can go. We need to distribute this 3. It needs to be multiplied by every term inside here. So we end up with 3 times x squared, which is 3x squared. 3 times positive 1x is positive 3x. And 3 times negative 6 is negative 18. And that's the expanded form. We're finished there with that. Okay, in comparison to what we had just done, I know you like that. In comparison to what we just done, we got to factor this one here. Like I was saying, we're doing the reverse of what we're doing now. So in this one, they want to just expand and simplify. The reverse of that is called factoring. Okay, so we're going to be factoring this equation. Now, I don't know if you recall factoring. This is a quadratic, so what we're going to do is a special type of factoring. I'm going to find the factors of the first term. Does this ring a bell at all? And factors of the last term. So, factors of 3t squared would be 3t and 1t. Okay, those are two numbers that multiply to make that. Factors of 3 are just 3 and 1. Okay, those are the only factors. Now, technically, with other numbers, you're going to get lots of columns worth. We're going to see if their products add up to the middle term, which is positive 6t. Oh yeah, it does. Good. So we test this out. Well, because there's only one column in each, this is pretty straightforward. We're obviously going to have to multiply these. But let's try multiplying across to start. 3t times 3 would give us 6t. 1t times 1 would give us 1t. Can I add or subtract that to get 6t? No, so that didn't work. The only other option is go across. 3t times 1 is 3t. 1t times 3 is 3t. Can I add or subtract those to get 6t? Yes. Okay, so this is what we're doing. I'm going to get 3t and 3t. They're both going to be positive, okay, when I add them together, so which means these two both have to be positive. Okay? Now what I do is one set goes into the first, one is the first terms in the brackets, another one is the second terms in brackets. And what I mean by that is I set up two pairs of brackets. My first terms, I'll be the first term in each bracket, so I'm going to get a 3t and just t, or 1t. Okay? And the second terms in brackets are going to be the other ones. Now, this is the tricky part, if you're already confused. 3t was multiplied by 1t. That means the 3t and the 1 have to go in opposite brackets. So I put plus 1 in this bracket. The 1t and the 3 were multiplied by each other, so the 1t and the positive 3 have to go in opposite brackets. So when I rewrite it, the factor form of that is 3t plus 3 multiplied by t plus 1. If you were to expand and simplify, you would end up back here. Expanding and simplify is what we did in the question before. Okay, let's factor this one. It should be a little more straightforward. Factors of x squared. What coefficient is technically in front of this? What are the factors of 1x squared? 1x times, that's it, right? Cool. Factors of 15.
15.
And?
3.
Yep.
5.
Good. That's it. Those are the factors. Okay. Now we know their product, when we multiply across, it's got to add up to our middle term. Okay? This is our middle term. So plus 2x. Now, this one's a little bit better example. Even though there's only still one column over here, there are two columns here, so we're going to have to trial and error through this. Now, when I multiply across, 1x times 1 is 1x. 1x times 15 is 15x. Can I add or subtract that to get 2x? Doesn't work. And if I go across, does anything really change? No. So did this column work at all for us? No. So that's not going to be one of our answers. Okay. Let's try the other way. 1x times 3 gives us 3x. 1x times 5 is 5x. Can I add or subtract these to get to positive 2x? How? What do I have to do with one of the numbers? You're 100% right. 1x times 3, 1x times 5 is going to give us 3x and 5x. I can change the operations in front of one of these numbers. Which one should I change?
3.
Yeah.
Negative.
Good. Because negative 3x plus 5x gives us positive 2x. Now, let's check this. What that means is the number I multiplied by to get 3x was 3. So that means this needs to be negative now. Okay? Here's our check. Positive 5 times negative 3 is what?
Negative 15.
Negative 15, and that's exactly what we had there, right?
Yeah.
So that's our check. So we definitely know we have the right numbers now. So again, these will be our first terms, and these will be our last terms in the brackets. So in our brackets, we go to put them in again. The red ones are the first terms. So I'll underline those. And the last terms in the brackets are this column. So we get 1x, or just x, just x. Now again, we technically have to go in opposite brackets, like we did in the previous question. I multiplied 1x times negative 3, so 1x and negative 3 got to go in opposite brackets, right? And then same idea with 1x and 5. 1x and 5 got to go in opposite brackets. But here's a question. Did it actually make a difference which one I put them in? Did they still end up with 1x in their bracket? Yeah, so because these two were the same, it didn't actually matter. Now when they're different, like in this question here, where I had a 3 and a 1, very important that we put them in opposite brackets. But because our first terms were the same numbers, it really didn't make a difference down the road. So our final answer, without any special colors or anything, is the same as above. It's just x plus 5 times x minus 2. Okay, in this question, they want you to factor this now. Problem is, first of all, we're used to seeing things that look like this. This is called the parent function of one of these, okay? So we're used to seeing y squared plus x plus, okay? And normally we have some coefficient for a, some coefficient for b. Oops, there should be a plus sign there. Plus bx plus c, okay? If you notice in this one, oh, geez, what have I done? It's a big sign. That should say bx, okay? If you notice for this one, there really is no middle term. We're only dealing with two terms, okay? This is still a quadratic. There is a way to factor this. It's called if it is a difference of squares, okay? And a difference of squares means you have a function, and I should stop using y because I think you guys are going to mostly use f of x this year, okay? F of x is equal to a squared minus b squared. If this is the case, then this can be factored into two brackets, where the square root of a is your first term in both, square root of b is the second term in both, and you just put a plus and a subtraction sign in there. called the difference of squares. Okay? So, first of all, I have to make sure I can find the square root of the first term and the last term, and I have to make sure, because it's called a difference of squares, it's a subtraction question. Okay, so difference of squares. Now, is this a subtraction question? All right, we got the difference part. Can I find the square root of 121? I'm going to tell you you can. Okay, square root of 64. Do you know if we can find that? No? Well, let me make a guess. I'm giving you an example. What do you think?
Yeah.
Yes, there you go. Good guess. And we can find the square root of x squared. So what we're going to do is we're going to do a little side calculation here. I'm going to try to find the square roots of both the first and second term. Square root of 64x squared. Square root of 64? No? Two numbers that multiply to 64? Something times something. It's not 7, it's not 9. Yeah. 8 times 8 will give us 64. And square root of x squared is just x. What I'm saying here is 8x times 8x would give us 64x squared. Does that make sense?
Yes.
Okay. Along those same lines, another side calculation here. 121. Let's find the square root of 121. You'll probably have to refer to a calculator for this one. 121 square root is 11. Okay. So what we're saying there is 11 by 11 would equal 121. So we've got our terms. So what we're saying now is I can put these into two brackets. The first term I'll put into the brackets is my 8x. The second term I'll put in, we'll do it in blue, is my 11. And what operations do I need to put in? So essentially your answer is, without any colors, it's the exact same as above. 8x plus 11, 8x minus 11. And that's it. That's in factor 4. Okay? It's actually a very easy one to do once you get the process, but you have to be able to recognize it's a difference of squares, and that's the hard part to that. A perfect square trinomial is they're going to give you a long version of looking at this. And perfect square trinomial is essentially, how do we write this? A x squared plus 2 a times b. I'm sorry, this should be a squared. And then plus b squared. Okay? And what that means is this can be written in factored form as a, oh, I should put an x there. So actually, let's get rid of this x. I'll just say a squared. This is how they're going to represent it. A squared plus 2 times ab plus b squared can be represented as a plus b. And we just write it like that. Remember the very first one I asked you about? What does that mean? Okay. Now we're using letters, so I'm going to show you what we're talking about numbers. A perfect square trinomial, if you recall, I'm going to show you a quick example. If we expand it, what's going to happen is we get, let's say we have 2x plus 4 squared. Okay? Say we expand and simplify. So what this means is 2x plus 4 times 2x plus 4, right? So when we go to multiply those, 2x times 2x is 4x squared. So we're going to FOIL again, right? First term. Outside terms, 2x times 4 is 8x. 4 times 2x is 8x again. And 4 times 4 is 16. So what we're talking about here, when we combined our like terms, 4x squared plus 16x plus 16. This right here is a perfect square trinomial. Okay? Trinomial means there's 3 terms. Okay? And the reason it's a perfect square is because if I factor this, it ends up looking like this, two brackets that are the same, or two brackets that are the same. And now, referring to what we were talking about out here, okay, all they did is we took 2x plus 4 squared, right? But what they did is they said, take your first term and square it. So our first term is 2x. 2x squared is 4x squared. Okay. They then said, take the a term, which is our a term, and the b term, and this is our b term, multiply them together, and then multiply by 2. So they're telling us multiply 2x times 4, and then multiply by 2. So in other words, plus 2. And then what's 2x times 4? 8x. And finally what they're saying is take this b term, your last term, and square it. So what's 4 squared? 16. So now what we have is, I'm just going to multiply that part, 4x squared plus 16x plus 16. Again, the exact same thing we have down here. Okay? We're just trying to talk to you about shortcuts. Now, perfect square trinomial can be a pain to try to recognize. So what I'm going to tell you is you can find a perfect square trinomial doing the exact same factoring we did. Just at the very end, you need to recognize that both numbers in the brackets are the same. So what does that mean? Let's see. I'm going to take this. Remember I said we're going to factor it and it's going to become this here? I'm going to factor this. 4x squared plus 16x plus 16. So we were just doing factoring. Find the factors of the first term, which are 1x, 4x. Any other factors?
2 and 2.
Yeah, good. And what about the factors of the last term?
16, 2, 7, 8.
Yep.
4 and 4.
Nice. Now we know the product's got to add up to our middle term, which is our 16x,
Yeah.
right? So there's a lot of terms in this one. I got to go through 2 pairs over here, and then I got 3 columns of stuff to multiply over here. I'm going to go through this really quickly. 1x times 1, 4x times 16, that's 1x and like 54, I think. Not even close, right? 4x and 1, 1x and 16, 4x, 16x. Are they going to work? Nope. We can't cross it out yet, though, because I haven't tried it through this column. 1x by 2, 4x by 8. Going to give us 2x and, what was that, 32? Is that going to work? Nope. 4x by 2, 1x by 8. That's going to give us 8x and 8x.
Yeah.
Oh, wonderful, that works. Really chose a bad number. This is not what we're looking for. I just happened to choose a bad example. Okay, but it can be factored that way, 100%. The reason that is, I did choose a bad example, is because there is a greatest common factor here of the number 2. I can take 2 out of all of these, alright? For the sake of argument, let's for some imaginary reason say that didn't work, okay? Even though I very obviously did. 1 by 4 and 4 by 4 gives us 16 and 4. That's not going to work, okay? So the idea to this is the first column did not work, we're going to say. Now we're dealing with numbers that are the exact same.
Yeah.
2 by 1, 2 by 16 is 32 and 2. Going to work? No. And if we go across, is there going to be difference? No, because we're using the same numbers, right? 2 by 8, 2 by 2 gives us 4 and 16. Going to work? If we go across, so that's 2 columns we've gone through now. This one never worked, and this one never worked. Let's finally try this one. 2 by 4 and 2 by 4 gives us 8x and 8x. Does that work?
Yeah.
Yes. This is what we're trying to get at.
Yeah.
Okay. So we finally factored this out. Like I said, let's pretend that other version didn't work. It's because of a mistake of the type of question I chose. We go to put it into the brackets. Our first terms are going to be what?
2x and 2x and
Yeah.
4 and 4.
Notice anything about this?
It can be simplified.
Yes. How can we simplify?
You can do 4x squared.
Now you're expanding again. This could be simplified by just saying 2x plus 4 squared. Right?
Yes.
That's what a perfect square trinomial is. It's kind of like a difference of squares, right? Except that we represent it like this. Okay? This is all we need to do to represent it. It's a special case. Okay? So it can be represented in one bracket. They want you to know this idea because it comes in handy later down the road in this course.